Welcome. In this video we will go through the latest developments for mesh and geometry in ANSYS 2025.2. We will start first with the Sketch 3D ribbon page, then the geometry and finally surface, middle and volume mesh. A new functionality has been introduced in ANSYS version 2025.2, which allows for creation of polygon 3D sketches. The workflow introduced is really beneficial for meshing non-circular cables. The function polygon is by default hidden in the design group. It is consisted of three main options: inscribed, circumscribed and edge. An option to define side number is also present. On a pre-existing curve, simply hover and select a point to create the polygon, or at the endpoint, click Tab to switch to selecting the orthogonal plane. By clicking spacebar you can manually set the radius of the polygon. Then fill the polygon and mesh it. A forced quad algorithm is going to be used for the mesh of the face, which is going to be described with more details later. Afterwards, a circular pattern algorithm is used to finalize the result. Then release the mesh from the geometry. Lastly, navigate to the volume extrude, select the shells as source, skip the target and use the curve as a guideline for extrusion. With this workflow, a non-circular cable can be solid meshed efficiently. In the past versions, mesh quality fix could be performed only massively at surrounding elements or nodes. Single node fixes require drag and drop operations by direct edit. From now on, there is a capability to repair violating elements at single node by simply clicking on the node while being at direct edit mesh. ANSYS automatically moves the point at a non-violating position. Also, the collapse edges functionality has been now implemented inside direct edit mesh actions tria edges. From now on, when two tria elements are opposed and next to each other, no drag and drop operation is required, but instead, a simple click collapses both elements by the selected edge. Moving on, a new function is available in geometry: the repair. Repair consists of three options: the old heal, the old rebuild, plus a new option, the refit, which refits geometry to topology. To execute it, choose between faces or faces connectivity, optionally provide a tolerance or G1 continuity and select the desired faces. Note that the new refit is equivalent to the option fit topology to geometry in the outputs. Geometry is now correctly fitted to the existing topology. The loft functionality has been also vastly improved. In the design group of functions, the loft function is now consisted of two functionalities, the loft and the parametric loft. It has a new unified layout, providing result options, 3 methods plus mesh-related tools. Finally, the new loft has also advanced capabilities in handling specific parts where the fill function would fail. Moving on to the surface mesh, the Simplify Macros function has been also enhanced. The slide bar has been replaced with a drop-down menu of options. Two new options have been added, the Extra Draft and the Aggressive. Those options are really beneficial when simplifying sub-D components. A new tooltip is also added with explanatory information on each option. By choosing Aggressive, for example, and clicking Run, those visible sub-D components can be quickly simplified. In the beginning of this video, a reference has been made to the new forced quad algorithm. This option has been introduced to aid in producing a pure hexa mesh on axisymmetric components. For the explanation of the new algorithm, an axisymmetric component is going to be used, a pulley. The part is plain cut in half, and everything is deleted except from the section face and two 3D points as shown. The forced quad option is used to generate pure quads in the section face. Then, the volume mesh extrude function is used to produce a solid mesh by using the revolute rule. This way, by having a pure quad mesh on the section face, a pure hexa mesh can be then created. Mesh result on dents has been highly improved in this version. Dents are now recognized as a feature of a stamp type. Simply recognize them through features or through the relevant option in the mesh settings. The enhanced treatment is applied if the option stamps treatment is enabled. Note that for specific types of dents and treatments, the DM library can be still used. A new option has been added in Hole 2D treatment, Advanced Options, called Apply Full Symmetry. When the option is activated, all holes 2D within max diameter that have symmetry are treated by fully respecting the symmetry. The line edit, with default value 0.1 times L, governs the distance from geometry that we are allowed to deviate from, in order to achieve fully symmetric mesh, with fourth decimal accuracy. The symmetry axes are identified from the geometric description. It works for all holes with symmetry axes recognized using the provided tolerance. Upon meshing, all nodes have the same distance from the symmetry axes with their symmetric counterpart, and all edges have the same length with their counterpart. Inside perimeter spacing, isospace, a new option has been added which is named Highlight. This option gives the ability to highlight on the model either the non-isospaced or the isospaced perimeters, based on a given tolerance. The same option is also embedded in Direct Edit Geometry. Regarding to pure FE mesh, now side curvature on fillets is preserved when adjusting nodal count. For this demonstration, curves are used to mark initial fillet position. In four-sided, increasing or decreasing nodal count won't affect curvature of the fillet boundaries. Additionally, the ability to generate trias has been also implemented in four-sided. A new function, the transfer, has been released, to copy the mesh from already meshed parts to new similar geometries. Now similar models should no longer be meshed from scratch, but instead they can get a copy of the existing mesh. Simply merge the two similar models together. Access transfer, and for this purpose, use the match option. Source shells and target macros are first selected, and then projection distance and snap tolerance are also defined. Select source, confirm, select target, inspect fully and partially matched areas and then confirm. Optionally mark result shells as frozen delete by enabling the option. The same principle should be applied to partially symmetric models with minor differences. For this occasion, the mirror option should be used. The symmetry plane must be correctly specified, which can be either 2 points or 3 points normal, or if suited, default symmetry plane. For the next step, source and target should also be carefully defined. The tooltip explains what color is used for source and what for target. Lastly, as before, confirming shows a preview of fully and partially matched areas, then confirming again shows the final result. There are models that are self-symmetric and have to be meshed. Instead of meshing the whole model from scratch, use the transfer mirror option to copy the mesh from the half of the model to the rest. Make sure to have the model separated in the middle with a yellow curve. Select the symmetry plane and then confirm. This way the mesh from the half of the model gets copied to the rest and only the dissimilar areas have to be inspected. Note that result shells are by default marked as frozen delete unless the option is clicked. Lastly, transfer mirror can be also beneficial when dealing with features in similar instances. Both source and target have to be manually selected. Then a 2 or 3 points normal symmetry plane is defined. And finally, upon confirming, the mesh is copied. Perimeter simplification can also occur. Moving on to the mid-surface casting, a new option has been added to the Configuration tab. Exclude joined perimeters as called. This option controls if joined perimeters will be imprinted to the casting result or not. This comes in pair with an additional feature, the automatic perimeter simplification performed by casting. In other words, casting decides which perimeters are needed for the mesh result and it excludes the rest from imprinting. This way the middle mesh now contains only the essential perimeters needed as the rest are not transferred from the geometry. Also, the option which controls better quads orthogonality and higher length accuracy from surface mesh now exists in casting as well. In the middle, a new option has been added. Overmolding is a multi-step injection process where two or more components are molded over top of one another. There are two different cases of representations, the intersected and the slotted. The meshing procedure is similar for both, so the intersected will be demonstrated. The major difference between them is the way one part is molded over the other, with the slotted featuring a slot, so the sheet metal is overlapping with the plastic. For the intersected, the layout is identical to casting, while for the overmolding slotted, the layout is also identical, except from an additional merge parts options, to define faces distance and cons snap distance. Upon executing, this is the mesh result outcome. 3 different PIDs and 3 different macro areas for the plastic, the sheet metal and the intersecting area. It's essential to note that only for the intersected, nodal thickness on the intermediate macro is the sum of the 2 other macros. This can be also visualized with the draw shell as solid option. Regarding to fillet treatment, now there is an ability to provide fillet treatment on thick areas inside casting. In the Casting, Thick Areas tab, Fillets, simply edit treatment or create a new one, such as changing the rows of elements to specific, let's say 4. Regarding to casting and thick areas, an additional thick areas treatment has been implemented, the solid skin and 1 row. This option is beneficial when dealing with hybrid mesh, and interface shells are needed between shells and solids. Now, instead of manually creating interface shells from solid facets, this option automatically creates them beforehand. In the extruded cross-section, a new option has been added, the Create Cross-Section Face. Choose a point to define a plane normal to perimeter and confirm. Now, except from the FE shells, a face has been also generated. This operation can be beneficial for complex shapes with bends and cuts at an angle, as well as for multiple neighboring components that should be meshed with a node-to-node connection. The face that belongs to the thick area can be separated with cuts. Then, middle curve can be generated for the rest of the face, projected onto it. The separated area can be meshed with the new forced quad algorithm, so it can later be volume extruded. The curves can be extruded to generate FE shells. When both operations are done, a hybrid mesh will be generated. Moving on to the volume mesh. In the volume mesh settings, the option Force Rows of Tetras and Thin Walls has been now enriched, with the ability to force 3 or 4 rows of elements instead of only 1 or 2. So selecting 3 for example will force 3 rows of tetras on thin walls. In the mesh settings, fillets, a new tool has been added, which creates ortho trias at fillets, while having trias on the rest of the model. It is called Create Orthogonal Trias. Additionally, on the Holes 3D tab, a length option has been implemented, which allows for specific element length in 3D holes. This is beneficial for when local refinement is needed. The Define Stack Mesh function has a new option, in both direction and base functionalities, the Exclude. This is useful if FE entities already exist, to exclude them from the build area. So as always, the first step is selecting faces or faces connectivity, and then optionally an exclusion of existing entities can be made. The most important in this function is the new addition of the domain functionality. This has been introduced to provide with the ability to mesh domain boxes that will be filled with mesh inside. This is essential for when meshing battery frames that contain material such as foam. The procedure is similar to the other two, except from the first step, which is the definition of a domain box. Block heights can be either set to auto or they can be manually defined. Upon executing, the whole domain box is filled with solids. It's important to note that the foam-related mesh has been automatically assigned to a new PID. Lastly, in the Hexablock ribbon in the Special Tools, a new function has been introduced, the Bolt. This function automatically generates volume mesh for bolts, and is really useful especially for bolts with irregular shape. First, the faces of the geometry are selected, and then optionally one or more pretension planes can be defined through cons selection. In the spacing, there are two methods to choose from, length and auto. In the length, the element length is manually defined. There is also an OGrid flag which, when activated, generates an OGrid. This can be applied to core pattern as well. After running, the volume mesh is ready. The one demonstrated is with pentacore and no pretension planes. Thank you for watching.